Okay, now we move into the chapter calculus. Okay, I do uh, before I start with the chapter. I want you to look at the graphs of straight line. Okay. Remember when we did the graph of straight line, uh, say y of 2x minus 1. Okay. Say if I have this graph, the line I will have a straight line, and it would look like that. Here should be half. Okay. And when when we're doing straight line, we know every straight line has a gradient m equals to 2, okay, which is this number, the coefficient of x. Okay. We call it the gradient. Okay. The physical meaning of gradient m uh, is that, so for every unit increased in x direction, okay, the y value of the graph would increase by m units. Okay. In this case, in this graph, for every unit increased in x direction, the y value will be increased by 2 because m is 2. Okay. For instance, in this graph, when x equals to 0, y is equals to minus 1. And we substitute it in, find y is minus 1. And because the gradient of the graph is 2, and it means if x increased 1 unit, the y value would increase 2 units. So minus 1 increased by 2, then the y value will be 1. Okay, we can substitute x equal to 1 to this equation to check whether the statement is true, and it is true. Okay, because when x equals to 1, I have 2 times 1 minus 1 will be 1. Okay. Similarly, when x equals to 2, okay, y value would our y value will be increased by 2 again, which is 3. So when x equals to 3, the y value on the graph will be 5. Okay. Because we know the gradient of the graph, we can just keep going doing that. Okay. And this is the property of the gradient. You can also consider the gradient as the the gradient is a measurement of the slope. Here, if the gradient is higher, it means it is more steep. Also, and similarly, it means for every 1 unit increased in x direction, the y value would increase more. That means you have a more steep slope. Okay. For instance, if I have a straight line y equals to 5m, okay, 5x, and in this case, okay, m is 5. Okay, and from from this from the gradient, I know I have a graph, a very steep graph, okay, like this, x and y coming through the origin. Okay. So when x equals to 1, the y value should be 5, because x is increased by 1 unit, y value should increase by 5 units. So when x is 2, the y value on the graph should be 10. Okay. Similarly, if I have a minus number as a gradient, for instance, if I have minus 2x, okay, from chapter, I think it was chapter 2, when I did a tutorial on how to sketch the graph. Okay. When we have a minus number, the shape of the graph became like this. Okay. So when I sketch the graph should be something like that. Okay. And the gradient is minus 2. It means for every unit increased in x direction, the y value of the graph would increase by minus 2 units. So that is, the y value will be decreased by 2 units. That's why we have the graph in this shape if the gradient is a minus. Okay. For instance, if x is 0, y will be 0. Okay. So when x is 1, your y value should be minus 2. Okay. Because the gradient is minus 2. Okay. And from this graph is very and when we look at the graph of straight lines, what we can say is the graph of straight line, the gradient of straight line are constant. Okay. No matter where's your what is your x value, it has a constant gradient. So at any point of the on a straight line, the gradient is constant. Okay. Okay. And this is what we do in the chapter of calculus. Okay. In calculus, in math method is basically about finding the gradient. For finding the gradients. Okay. And it is about 60% of your year 12 final exam. Okay. It takes 60% of mark in your year 12 final exam. It's a very important chapter. Okay. And yep. Okay. Okay. Moreover, okay, from okay, I do some. Yep. I need a new page. Okay. Moreover, when we have a gradient, when the gradient of a straight line is positive, okay, it means on the graph, when x increases, y increases. So when the gradient is positive, it means when x increases, as x increases, the y value increases. Okay. Also, if the gradient is less than 0, say a minus number, it means as x increases, your y value decrease. Okay. For instance, here. important part is when the gradient is 0, it means there is going to be, sorry, minus should be there. Okay. In a straight line, it's going to be a horizontal line. Okay, it means nothing is when x increases or decreases, the y value is the same. Okay, so this is the property. So when I say a graph, okay, so when I watch a graph, I can know the gradient of the graph at any point by sorry, I can know whether the gradient of the graph is positive or negative using these three rules there. Okay. For instance, let me show you something like that. When we have a graph of y equals to x squared, which is parabola, okay, I would have this graph. I would have this shape of the graph. Okay. Say if I have a point P there and a point say Q here. Okay. At point P, the gradient of the graph is minus number, is less than 0, because at the instant of point P, okay, when x increases, your y value is decreasing, so I will have a minus gradient at point P. However, at point Q, okay, the gradient is positive, because when at the instant of point Q, when x value increases, your y value is going to be increased in the graph. See here, okay, it's so the gradient of the graph at the point Q is going to be positive. Okay, and say it moves there, and actually moves like this. Okay, so okay, and look at a parabola graph. Okay, actually every point on the graph has a different gradient. Okay, also at this point, the turning point, okay, the gradient of the graph is actually 0. Okay, because at this instant there's no rate of change, and there's no slope. Okay, so I will do some more question on this. So okay, just remember, only in a straight line the gradient of the graph is constant. Okay, so in other graphs, such as a parabola or exponential graph, the gradient of a point on the graph is different. They are very different. Okay, and this is what we're going to do in the chapter of calculus. We need to find the gradient of a point on a graph.